Hello everyone, my name is Raman Sridhar and I'm Product Manager for Vibration Controllers here at Data Physics, and today I'm going to be going through how to configure and run a high channel count test. So the agenda for today, I'm first going to show you how to connect the hardware up, what connections to make. Then I'm going to show you how to configure our software to use multiple chassis. And then I'm going to actually set up a test and run the test and make a measurement of the phase between different chassis. This is a picture of the systems I'm going to be working with today. These are three of our Abacus 912 chassis, each one with 72 channels for a total of 216 channels. But the process is the same, whether you're using the 72-channel Abacus 912, the 36-channel Abacus 906, the 6-channel Abacus 901, or some combination of the three. So to connect the hardware, you're going to take a standard RJ45 gigabit network cable and connect it to the top network port on the very rightmost card, and connect the other end of that to a network switch. And you're going to go ahead and do that for all of the chassis that you are connecting together. This provides a data connection between the chassis and from the chassis to the PC. You're also going to be connecting your PC to the same network switch. The final step in connecting the chassis is to connect the clock synchronization cable. With an RJ45 cable, connect the clock out of the first chassis to the clock in of the second chassis, and repeat for any subsequent chassis. The order in which they're connected here determines the order that the channels will appear in the software. Now coming into our software, I'm going to create a new test and create a transfer function test. I'm going to give the test a name, and then I'm going to go into the channels tab of the setup and tell it what order I have connected daisy chain my chassis in. So I click on Edit System in the top right corner of the Channels tab, and I go ahead and select the three chassis in the order that they're in. I can click on Validate All here, and that's going to validate my chassis, make sure my clock synchronization cable is in fact in this order, and I get a pass, which means that everything looks good. So I'm going to hit OK, and now my channel table is going to be updated with this new chassis information. I can click on the Inputs button, and I can get a graphical view of my channel numbers using the left and right arrows to move between the chassis. I can click the small All button, and it'll select all the channels on the current chassis, or the big All button, and it'll select all channels on all chassis. I'm going to enable an output waveform here, a random waveform that I'm just going to tee into a couple of different channels to measure the phase between them. One thing I can do to quickly edit many channels, I can select in the left-hand column to multi-select, then right-click on any field and make a change, and that change will then apply to every single column in the grid that's selected. So I'm going to change these to be 100 millivolt per G accelerometers, and then deselect everything. There's lots of useful features in our software for dealing with this many channels, and one of them in particular I'm going to point out here is the little filter icon on each of the column headers that appears in the top right corner when you hover over it. And if you actually click on it, you can actually apply a filter to that column, and we're only going to display the channels that meet that filter condition. So for example, I can say I want to display all channels greater than 100, and I click OK, and it'll display all of my channels that are greater than channel number 100. One other useful tidbit I want to point out here is in the channel number column, or the BNC column, you can see the overall BNC number, which obviously represents the multiple chassis daisy chained together. And then in parentheses, we have the actual chassis number, so chassis number 2, for example, and then the BNC number on that chassis, and that's going to correspond to the actual BNC, the number written by the BNC on that particular chassis. So for example, channel number 101 in the overall system is chassis number 2, BNC number 29. So you can easily look at chassis number 2 and find channel 29 on that. It's printed on the chassis, and you know exactly what channel this row in the setup corresponds to. So I'm going to go ahead and clear my filter here and move on to my transfer function setup. I'm just going to do a default test here at 20 kilohertz bandwidth. You can see I've got all my channels listed here that are going to be part of my measurement, and I can select any one of them to be the reference channel. So for this test, I'm going to leave channel 1 as my reference channel, and I'm going to go ahead and hit run to open up the test in the run test screen. Now for my Bnc configurations, to start this test, I'm going to connect my output channel 1, which is the last Bnc on my first chassis, to my input channel 1 and input channel 2. Now you can tell that that channel is an output channel. If you were able to get up close to that channel, the bottom right Bnc, you can see that the LED next to it is flashing blue instead of green, which green would signify that it's an input channel. So I'm going to go ahead and click Initialize and start my test. And once my test starts, we're going to see data populate the screens. Now these are just the default plots that we have on the screen when we create a new test. A couple time signals, a spectrum, and then the transfer function between my channel 1 and 2. Now right now, channel 1 and 2 are teed together, so I'm interested in seeing the phase between channel 1 and 2 for this test. So I'm going to delete my other graphs, go into my graph attributes for my channel, my transfer function, and switch it to display the phase instead of the magnitude and the phase. So we're on a single chassis here, so we expect the phase to be extremely good, but one benefit of the 900 series systems is that the phase remains extremely good even when you measure across different chassis, and that's because we have a dedicated time synchronization cable that goes between each chassis that keeps everything in phase. So I'm going to go ahead and switch my Bnc now from channel 1 and 2 to channel 1 on the first chassis and channel 1 on the second chassis. I'm going to come back into the software, and I'm going to, we can see the phase for channel 1, 2 start to go awry, which is expected. And I'm going to right click on the plot and select signals or add signals and change it to the appropriate channel that's actually connected. So I'm going to use the filter to do this. I can enter, I want, the channel number I want to see, which in this case is channel 72. And I click OK and add my transfer function between channel 1 and channel 72. And now I'm going to be looking at the phase between channel 1 on the first chassis and channel 1 on the second chassis. And you can see it's still about 1/10 of a degree, which is still extremely precise at 20 kilohertz. Now I'm going to do the same thing, switch to channel 1 on the third chassis. So measure the phase between chassis number 1 and chassis number 3. Back into the software, we can see that the phase of channel 1 and chassis 1 and chassis 2 starts to go awry. I'm going to change that to be chassis 1 and chassis 3. And we're going to see that the phase between all of my chassis, all the chassis are still maintained to be very, very precise. So you can see chassis 1 and chassis 3 are also within 1/10 of a degree out at 20 kilohertz. And this is the design of the 900 series platform. It doesn't matter how many chassis you add on, we compensate for everything to make sure that the first chassis and the last chassis and every chassis in between is simultaneously sampled, and that your data integrity is maintained regardless of your channel count. The other point I'd like to make here is just how simple it is to set up a test like this in the 900 series software. It's just a matter of daisy chaining your clock synchronization cable and then checking a box to tell the software which order you've daisy chained them in, and the software manages everything else from your software license to the time synchronization, and all you've got to do is set up your channel table and click start. Alright, with that I'm going to close out this presentation. I hope this has been informative. If you have any questions, please feel free to reach out to myself, Raman Sridharan, or to your local data physics representative.